Hey everybody, welcome to PC Perspective. I'm Ryan Shrout. Today we're going to talk about a new feature in the latest update to Windows 10 that I don't think many people really know about, but I found to be very, very cool. If you remember back when the Intel Skylake architecture was first kind of revealed completely at the Intel Developer Forum back in August of this year, they talked about a feature called Speed Shift, and it was the ability for a microcontroller on the processor, essentially the CPU hardware itself, being able to determine when it should increase its clock speed or decrease its clock speed, as opposed to depending completely on the Windows operating system itself. The proposed advantages of that were that you would be able to see boosting up to certain clock speeds or up to its maximum clock speed in a much shorter interval of time, thus allowing you to get the most performance out of your processor in a shorter time span. They gave examples of why that would be beneficial, and a lot of it is in terms of touchscreen integration, scrolling, user interactivity, those types of things. Now the caveat there was that upon Skylake release and when Windows 10 was released, it wasn't enabled in software. So even though the hardware had support for it, Windows did not have support for it. Last week, Windows 10 version build 10586 came out, and along with it, integrated support for speed shift technology. So, being as that we have several different Windows 10 Skylake-enabled laptops, including the Surface Book you see here, the Surface Pro 4, as well as the Lenovo Yoga 900, we decided to do some testing and evaluation on that. Now, we have three different ways to evaluate performance on it. One is with a custom-built application coded by Intel, and what this application does is it basically simulates a workload that, for those of you interested, just basically puts a value in a register, moves that value, moves it along, it cycles it in for some kind of defined loop time, but they do it in a way that the compiler can't optimize it, and then you measure how long that work takes to complete, and then you can calculate your clock speed based on that result, because Intel obviously knows how long that work should take to complete on its own architecture. And the results are pretty substantial, right? In our testing with the Surface Pro 4 as well as the Yoga 900, the pre-speed shift enabled version of the Windows operating system could take as much as 60 milliseconds to go from its base clock speed of about 800 to 1000 megahertz up to its 3.0 gigahertz maximum, right? So 60 milliseconds, that's not a huge amount of time. Obviously, if you're talking about frame rates or gaming or interactivity though, 60 milliseconds of input latency is significant. With the speed shift enabled version of Windows 10, we actually saw that increase or decrease down to 6 milliseconds. So we got a 10x fold improvement, going from 60 milliseconds to 6 milliseconds on the Surface Pro 4. There was a little bit less variance on the Yoga 900, but still a dramatic increase in how quickly the processor was able to go from its base clock speed to its peak clock speed. Now the benefit there is when you touch your machine, or you touch a touch screen, or even if you click with the mouse, the CPU has been idle for some amount of time. You want the CPU to go up as high as it can, as quickly as it can, so that whatever you are trying to do, whether it be touch an icon, or drag a window, or load up a JavaScript file from a web page, you want it to get done as quickly as possible. So that 60 to 6 millisecond improvement is a dramatic change in interactivity. The second set of results we have look at kind of your standard benchmarks, right? We have SunSpider, which is a JavaScript-based kind of industry standard benchmark, and then we have WebXPRT, which attempts to do 6 or 7 different web-based tasks like photo enhancements, or creating of photo albums, or measuring of stock, graphing out stock data and that type of stuff through JavaScript. And it happens all in a browser as well. We ran some of those benchmarks, and we saw fairly modest improvements, 5 to 8% increases in SunSpider or WebXPRT, depending on the browser. We tested both Chrome and Edge. So those are kind of moderate improvements, but do show that speed shift is in fact doing something to improve your general web performance across the board. Now the third test we did, which is more interesting and I think more indicative of how the change actually affects the user experience, was more unique, right? So what we did was we took the Surface Book here, and we tested it before, obviously, with version 10420, and then 10586, right? We tested in both instances. And we wanted to measure just how responsive is the screen to a touch command, right? So we did something simple like open up PC Perspective in Chrome and in Edge. And we wanted to see how quickly from finger touching the screen in motion, how long was there between when we actually started to move our finger versus when the screen responded. Now to do that, we used some pretty basic tools. We had the browser, we had our machine, we had a mirror here, which allows us to, we would actually put it on the side of the machine here so that we could see both the motion of the screen and the exact moment when the finger touched the screen and when it started to move, so that basically the mirror gives us the ability to see two angles in a video capture at the same time. We use this little stand here, and then we used a simple device like the iPhone 6s, which has the capability to do 240 frame per second video capture, which the higher the frame capture, or the higher the frame rate of the video capture, the more accurate you can be. At 240 frames per second, you're looking at 4.1 milliseconds per frame of how much time it takes up. So that's kind of our margin of error, plus or minus 4 milliseconds or so. So we basically would sit this here, we would put it to capture 240 frames per second video, put the mirror up here, and we would scroll, pause, scroll, pause. We would do that 4 or 5 times. We would repeat that whole test 3 or 4 times. We did that in Edge, we did that in Chrome, and then we did that with Google Maps as well in Chrome. And the results are actually pretty dramatic. If you look at PC Perspective in Microsoft Edge browser, you are getting like 70 to 80% improvement, decrease in the latency between when you start to move your finger versus when the screen starts to update, when you actually see the scrolling process take place. And I will say, even without the data and without the video, it was really obvious having a Surface Pro 4 and a Surface Book, one that had been updated and one that had not, but otherwise have identical specifications in terms of processor and compute power. The difference in the scrolling responsiveness was immediately obvious to me. And that shows to be the case when you look at the data and video and results that we have, we show you there, right? So you can see some real-time video of how the scrolling differs. And then we actually have, graph of the data results of what we calculated to be the actual latency, right? So you basically take the number of frames that existed between the time the finger first moved, when you saw the screen first move, multiply that by 4.16, and that is essentially your latency between movement and motion on the screen. So it was a really impressive result, and I don't think that I expected it to be that dramatic, right? When Intel talked about speed shift, it made sense technologically. It said, oh, okay, yeah, your ability to get to a higher clock speed faster is going to mean better user responsiveness. But I didn't really expect it to be this dramatic of a difference. And I'm a little bit curious as to why Intel isn't kind of going out there and really promoting the inclusion of this feature in the latest version of Windows 10, because I think that makes a pretty dramatic improvement in user experience, both on our Surface devices and our Yoga 900. Now, for those of you that are looking to upgrade to Skylake-based laptops, that will be in there. Your BIOS UEFI does have to have support for it. So far, all of the ones that I have tested have had support in for it as well. And on the desktop side, you will still see benefits of this. And as far as I'm told from my reps at Intel, pretty much every motherboard that ships a Z170 motherboard will have support for speed shift in it already, because it was part of the base code package. So in theory, I haven't tested this on the desktop system, in theory, you will get the benefits of speed shift with an upgrade to the latest version of Windows 10 on your desktop built machine as well. Now, make sure you go to PCPro.com, guys. I have more details on what speed shift is, how it works technologically, and obviously there's more data and graphs for you to look at there. Make sure you check out the full story. Otherwise, I'm curious to know what you guys think about this technology and our testing methodology, obviously, as well. Leave a comment here on the YouTube page or on the PCPro.com page, and we'll see you next time. Thanks, guys.